uses to determine the distance to reach a network. As we said, a metric could be hop count, for example. So a metric is the quantitative value used to measure the distance to a given network. Distance, it doesn't mean distance in meters or miles. A distance could be a hop count, could be a time delay, could be a bandwidth available at these links, for example. So the best path to a network is the path with the lowest metric. Lowest metric, less delay, less number of hop counts, okay? However, dynamic routing protocols typically use their rules and matrices to build and update their routing tables, okay? So the following table lists common dynamic routing protocols and their matrices. Routing information protocol, RIP, is used hop count. So if R1 wants to send information, to forward information to PC3, it could have hop count 2 and it could have hop count 5. For sure, it should choose the path with hop count is equal to 2. The metric is hop count. Each router along a path adds a hop to the hop count. Because if I start from PC1 and want to transmit to PC5, if this information, this message has been forwarded to the switch, this is hop 1. So now hop 1, and I will come back to this. Yes, imagine that we want to transmit a message from here to there. So when the message is transmitted to this is hop count 0. If it comes here, this is hop 1, 1. Add 1. Hop count equal 1. This is the next hop. So this is 1, this is 2, 3, 4. 1, 2, 3, 4, and this is the destination. Okay? Up shortest path metric is cost, which is based on the bandwidth, cumulative bandwidth from the source to destination. For example, the first link is Ethernet, the second link is serial, the third link is another fiber, for example, and there's also another path use Ethernet. So you calculate the bandwidth, cumulative, you add them, you add not the bandwidth, you add the value related to this type of bandwidth. So faster links are assigned lower costs compared to slower links. Enhanced Interior Gateway Protocol, it calculates a metric based on the slowest bandwidth and delay. Values, it could also include load and reliability into the metric calculation. So if the path from PC1 to path 1 from PC1 to PC5 with delay 10 milliseconds and the second is 15 milliseconds, for sure we will choose the 10 milliseconds, the router, okay? This is done. What's a load balancing? Load balancing, it means when a router has 2 or more paths to a destination with equal costs, cost matrices. For example, it has 3 paths and the 3 paths are with 5 milliseconds delay. What should the router do? Then the router forward the packets using both paths equally. This is called load balancing. So if we have the same cost on the 2 paths, the router will use the 2 paths to transmit or to forward this information. So the routing table contains a single destination network but has multiple exit interfaces. Okay. So I want to transmit to one destination, and the router has multiple interfaces, one for each equal cost path. So these three interfaces has 5 millisecond delay, 5 millisecond delay, 5 millisecond delay. In this case, the router should forward packets using these three interfaces, for example. Okay? If configured correctly, load balancing can increase the performance and the effectiveness. Why? Because if the destination will receive three packets, it will not lose any packet because at least it will receive it from one path or two paths or from three. Equal cost load balancing is implemented automatically by using routing protocols. It's enabled also with static routes when there are multiple static routes to the same destination network using next hop routers. We can also create load balancing using multiple static routes. We can't talk about load balancing in one route because it's the obligatory path to follow. We talk about load balancing at least two or more paths. Okay. Model practice and the quiz. This is for you. This is like summary. What did I learn in this model? The primary functions of a router are to determine best path to forward packets based on the information in routing table. This is a conclusion for you. We can read them together, or you can read them by yourself. Okay. So, okay. So the primary function of a router are to determine best path to forward packets based on information in routing table. Okay. The best path in routing table, remember, it's known as longest match, and the longest match is the route in the routing table that has the greatest number of far left matching bits with the destination IP address. Directly connected networks, what are they? Are networks that are configured on the active interface of a router. So if you configure IP address for an interface and this interface is up, this is directly connected network. A directly connected network is added to the routing table when the interface is configured with an IP address and subnet mask and is active, becomes active, no shutdown. Routers learn about remote networks in two ways: static routes with dynamic routing protocols. After a router determines the correct path, it can forward the packet on a directly connected network. It also can forward the packet to the next hop or it can drop. So three things. Directly it can forward to directly connected, to the next hop router, or can it drop. Three options, no more. Routers support three packet forwarding mechanisms. This is switching. Remember, fast switching, we add it in a cache. CEF, you have two things, FIB and the adjacency table. There are several configurations and verifications commands for router. So them, okay. And then a routing table consists a list of routes, non-networks. Routes, non-networks, prefix length. The source of this information is derived from many things. Directly connected networks that you manually configure. Static routes, also you configure them. And dynamic, you learn from routing tables from the dynamic routing protocols, OpenShortest path or other things. Source, the first entry of the IP route, remember. Every router makes its decision a lot based on the information it has on the routing table. He doesn't know about others information in other routing tables. So the information on a routing table of one router doesn't necessarily match the routing table of another router. They shouldn't be equal or something. Routing information about a path doesn't provide written routing information. It means that if I have routing from A to B, doesn't necessarily I should follow back B to A. No, it should be BCA, for example, or BCDA. Okay? Routing table entries include the route source, destination network, administrative distance, metric, next hop, route timestamp, and exit interface. This is an IP route, remember. Okay? Static routes are manually configured and find a explicit path between devices. Dynamic routing protocols help us to discover the network, maintain routing in tables, select best path, and automatically discover a new best path if topology changes. And this information should be maintained within the routing tables and update the routing tables. The default route, what's the default route? Specify a next hop router to use when the routing table doesn't find specific path or good path that match the destination IP address. In this case, a default route can be either static or learned from the routing protocols. This is IP version 4 tables still have a structure based on class 4 represented by Cisco used what is known as administrative distance. Why we use this? To determine the route to install it into the routing table. So Cisco operating system use administrative distance to add a path within the routing table. So the administrative distance represents the trustworthiness of the route. The smaller value, the path is better. Static routes are commonly used as default route forwarding paths to service provider. For routes outside the routing domain and not cleared by dynamic routing protocol, we should use static. In two cases, we should static. For routes outside routing domain, we can route information and not learned by the routing information. When the network administrator wants to explicitly define the path for specific network or for routing between stop networks, we use static. Dynamic routing protocol are commonly used in network consisting of large number of routers, and when a change in the network topology requires the network to automatically determine another path because we lose or we lost one node, so the path is broken. We should find another route. So as network grows, the dynamic routing protocol automatically learns about any network changes. Current routing protocols include interior gateway and exterior gateways. So the interior exchange routing information within a routing domain administered by a single organization. So IGP within single can be used only by single organization. However, the BGP, which is external gateway